Hi, welcome to Maths with Shayem A. I am Shayem A. Please like, share, and subscribe. Let's get to today's lesson.
Hi, today we are looking at the geometric sequence. Geometric sequence. Now, let's look at an example of a geometric sequence. We look at 2, 4, 8, like that. Why do we say it is a geometric sequence? It's a geometric sequence because it has a common ratio. In other words, when we take term number 2, which is a 4, and divide by term number 1, which is a 2, we get the same as taking term number 3 and dividing term number 2. So in this case, if we divide 4 by 2, we get a 2. In this case, we divide 8 by 4, we get a 2. So hence, we say this is a geometric sequence because it has a common ratio from division. So likewise, if we want to get to the next term, the opposite of ratio for division is multiplication. It means we have to multiply by the 2 there. So in other words, if we write our sequence, we have 2. If we multiply this by 2, we will have a 4. If we multiply 4 by 2, we'll have an 8. So if we want the next term, we'll take this 8 and multiply it by 2, which will give us 16, etc. and etc. So that's giving us a sequence. So this is a geometric sequence. Now, we are saying it's a geometric sequence. We know it's a geometric sequence because it has a common ratio. So common ratio represented by R, we now know that is term 2 divided by term 1. So it must be the same as term 3 divided by term 2. That is our R. So let's look at this. So we are saying that term number 1 equals to 2. And then term number 2, to get it, we will take this 2 and multiply it by the common ratio. In this case, we said it's a 2. And then to get to term number 3, we will take term number 2, which we said is 4, and we multiply it by the common ratio, which is a 2, like that. So if we say term number 1 is A, trying to generalize this, and the common ratio is R, our ratio represented by R, then to get the terms, we will say that term number 1 is A, term number 2 is A multiplied by R, which is actually AR, and then term number 3 will be term number 2, which we said it's AR, we multiply it by R, which gives us AR squared. Like that, we can even get term number 4, which is AR squared multiplied by R, so it gives us AR to the power 3. Right, so now we are able to see that, okay, if it's term number 1, if it's just 1, it will just be AR. If we put an exponent of 0, AR exponent 0, because it's 1, the R will have a 0 exponent, so AR to the power 0 is just A. Then if it's 2, it's AR to the power 1, so you see this is 1, so it's a 2 here, it's a 1 there. If it's 3, term number 3, then it will be a 2, AR to the power 2. If it's a 4, then it's AR to the power 3. So we can now use this to get any term. For example, if we want term number 10, we can simply say it's AR to the power 9. Because now it's a 10 here, then here it will be a 9. So generally, to get the general term of a geometric sequence, so we will say we want term number n, which will give us, it's AR. Now it was n. Remember, if it's 10, it will be 9. So if it's n, it now becomes n minus 1. So now we have the general term of a geometric sequence. So we are going to see how can we use the common ratio and also this common term n. Right, so let's start with how to use the common ratio. Remember, we said that we get the common ratio, which is R, we get it by taking term number 2 and divide it by term number 1, which is the same as term number 3 divided by term number 2. So this is how we get the common ratio. So we are going to take an example from Clever Maths, grade 12. The question is, determine the value of x. Determine the value of x if for x 2x plus 8, x plus 10 are the first 3 terms of a geometric sequence. Now, for x, 2x plus 8 and x plus 10 are the first 3 terms of a geometric sequence. So we want the value of x. So in that case, that's where we use the R. So we know that the common ratio R is term 2 divided by term 1 equals to term 3 divided by term 2. So we are going to substitute the terms. So in other words, we will have term 2, which is 2x plus 8 divided by term 1, which is 4x. This is the same as term 3, which is x plus 10 divided by term 2, which is 2x plus 8. So we can now do cross multiplication in this case. So 2x times 2x is 4x squared. 2x times 8 is 16x. And then 8 times 2x is also 16x. And 8 times 8 is 64. Now this is the same as 4x times x, it's 4x squared. 4x times 10 is 40. Right, so putting like terms together, 4x squared, subtract 4x squared. Now 16 plus 16 is 32x, so we have 32x plus 64 equals to 40x. So we take the 32 to the other side. So 40x minus 32 is 8x. So this equals to 64. So if we divide both sides by 8, we get the value of x to be 8. So the x value is 8 there. So we use the common ratio to can get the x value like that in a question like that where we wanted the value of x. So x is 8. So in other words, you can even substitute the 8 there and get the terms. So the terms will be actually be 32, 24, and 18. This was not asked. I just show you that if you put the 8 on the first 3 terms, you'll get that sequence. And the sequence is a geometric sequence. All right, so now we are going to see how can we use the n, term n, the term n formula. We said the general term, we said it's AR exponent n minus 1. Now we can use this general term formula simply firstly to just get a particular term. For example, if we have a geometric sequence 2, 4, 8 as before, and we simply want term number 9. So maybe we want to determine term number 9. So we can use the general term. So we will say term number 9, we put 9 here. So we know that term number 9 will be AR exponent 8 because it's term number 9. So we substitute the A and the R. In this case, A, which is first term, it's a 2. And then R, we have already done it, is 4 divided by 2 or 8 divided by 4, which is also a 2. And then this is to the power 8. So you can take your calculator and work this out. And then you get that 2 to the power 8 multiplied by 2. Or you can even add this exponents. So you actually have 2 to the power of 9. So the answer is 512. So you can use the term n just to get a particular term. So that's an easy example where you just use term n. So we can also use the term n when we are given 2 terms. For example, I'm going to take an example. We are given that term number 6 of a particular geometric sequence is 64, and term number 10, let's say the term number 10, it's 1024. So we are told that this is a geometric sequence. It's a geometric sequence. It must be stated so that we use the proper formulas. So the sixth term of a geometric sequence is 64, and the 10th term of a geometric sequence of the same sequence is 1024. So we want the values of A and R. We want to know the A and R. So we are going to use our general term for term n. So we have term number 10. We know that term number 10 is AR exponent 9. And term number 6, we know that it's AR exponent 5. So we have term number 10 and term number. So we are given. So in other words, we can just say the AR exponent 9 is given to be, remember, term number 10, they said is 1024. And then term number 6 is represented by AR exponent 5. And then they said that term number 6 is 64. So we are going to do simultaneous equations in these 2 equations. So this is equation number 1. This is equation number 2. So the best method for simultaneous equation here, you can apply any that makes us feel better. So, but here it's best to eliminate, to do elimination. We can eliminate the A. So how can we eliminate this A? We can divide this and that. So what we do on the left, we also do on the right. So we divide both sides. So when we divide, the A is eliminated. So we are left with R exponent 9 divided by R exponent 5. So we will get R exponent, you know the rules, 9, we take 9 and subtract 5, we get a 4. Right, so and then we can just take our calculators and divide 1024 by 64, and then we will get 16. Right, so now it shows that r exponent 4 is 16. So because this is even, we are obviously going to get two possible values of r. So we have actually r to the power 4. We can just simply do it that way and say this is 2 to the power 4. But this 2 can either be a plus or a minus. So it will give us a 16. So in other words, the value of r is a plus or minus 2. So the common ratio is plus or minus 2. Right, so we can get the value of a. We can take any of the terms that we had there. So let's take term number 6. We said that term number 6 is ar exponent 5, which we said is 64. And then we can substitute. Let's start with this positive 2. So if we put a 2 here, and then we have that as 64. So 2 to the power 5 is 32, so we will have 32a is 64. Now dividing both sides by 32, so the value of a will be 64 divided by 32, which is 2. So if r is 2, a will be 2. Now let's check if r is negative 2. So we will have a into negative 2 to the power 5, which is 64. And then negative 2 to the power 5 is negative 32. So we have negative 32a, it's 64. So we divide by negative 32, we get a to be negative 2. So in other words, if a is positive 2, r is also positive 2. But if r is negative 2, a is also negative 2. So we can use that to get any term. For example, if we are to calculate, let's say, term number 4, we will say it's ar exponent 3. So we can substitute any of this. So if a is 2, we'll have a 2. R is also 2 to the power 3. 2 to the power 3 is 8 times 2 is 16. Even if we substitute the negatives, so term number 4 will still be negative 2 for a, but we know also that r is also negative 2 to the power 3. So negative 2 to the power 3. We should remember, if we are not using our calculators here, we must start with the bracket first. Negative 2 to the power 3 is negative 8. Then negative 8 times negative 2 is 16. So both of them, for term 4, they give us 16. Right, so we are going to take another look of how can we use the general term. So we're going to look at, let's take the same sequence again. So we have the question. Let's look at this question. How many terms are there in the geometric sequence? In the geometric sequence, let's take the same sequence 2, 4, 8, and let's put the last term as 8192. So this it's a geometric sequence with terms from 2, 4, 8 up till the last term being 8192. So we want to know how many terms are there. The same question can be asked like which term is equal to 8192. So which term of this sequence, 248, like that, to 8192, which term is this? So this is the same question. The answer will be the same. For example, if whatever term number is there, actually that's what we want to know. It will tell us the number of terms which are there. So this is another example of where we use the general term. So remember, we said that the general term, term n, is a r exponent n minus 1. So in this case, the 8192 is the general term. I mean, it's the nth term rather. So meaning the nth term, it's 8192 in this case. So we will say our nth term, which is ar exponent n minus 1, is 8192. So it's our nth term there. So let's substitute, because we want to know which term is that. We're actually looking for this n there. So this n, we are looking for it. So let's substitute. What do we know? Already we have been using the sequence, so we already know that a is 2. We can see it. And then the r, also we have calculated that r is a 2. And then we have the power n minus 1. So this is 8192. Right, so to deal with this, we must be understanding our exponents properly. So there are two ways in which we can move from here. So we can divide both sides by 2 first, by this 2, both sides. Or we can even, because the bases are the same, exponentially we can have 2 to the power 1 plus n minus 1. So this is 8192. So we actually have 2 to the power n, which is 8192. So this 8192, we can rewrite it as 2. This is 2 to the power of 13. Now, let's see how we get this from the Casio calculator. Using the Casio calculator to move from here to that. So the Casio calculator may be able to help us to rewrite this in exponential form. So we press the number, you press 8192, and then you press shift, and then you press fact. Now you can see the fact there. It has a symbol with a lot of commas just below the root sign. Below the square root sign, there is the sign of fact. It's something like this with this commas. So that's the symbol that you use. And when you press that, it will automatically give you 2 to the power 13. Remember, you press the number, you press shift, and then you press fact. So it will give you the answer that you are looking for. But then if you don't want to do that, you can even still apply your log. So you remember this n equals to a log. The log is an exponent. So this n is a log of 8192, and the base is 2. So you'll simply get your 13. So it means, therefore, that 8192 is the 13th term. So it's term number 13, which is 8192. Or you can simply say there are 13 terms in this sequence. So that is how we use the nth term. So we use it to get the number of terms. Right, I'm going to take the last example. Now in this case, we going to involve both arithmetic sequence and geometric sequence, where we use the n, the term n. We are going to use both of them. So let's look at it as an example. we have the sequence 2x, y, and 9. Now, what is happening here? So we are given that, or we told that the first three terms form an arithmetic sequence, and the last three terms form a geometric sequence. So calculate the values of x and y. Right, let's look at this scenario here. So we have two sequences. They're saying the first three terms, in other words, 2x and y form an arithmetic sequence, while the last three terms, meaning the x, the y, and the 9, form a geometric sequence. So we want to know the values of x and y. Now, it is better to actually write this separately. Put the arithmetic sequence separately. So meaning the arithmetic is 2x and y, and then while the geometric sequence will be x, y, and 9. Right, so if it's arithmetic, it means that we have the common difference, which is term 2 minus term 1, which is the same as term 3 minus term 2. In other words, term 2 is x minus 2 equals to y minus x. So if we take the x that side, it will be plus, so it will be x plus x, which is 2x, minus 2, which is y. Right, so we can have this as an equation. So coming to this side, we know that the common ratio is term 2 divided by term 1, which is the same as term 3 divided by term 2. So we can substitute and have term 2 as y divided by x is the same as 9 divided by y. So if we cross multiply here, y times y is y squared equals to 9 times x, which is 9x. Right, so we are going to substitute this y value here so that we can solve for x. So we have y squared equals to 9x. So a y, it's 2x plus 2. So where we see y, will put 2x plus 2. So let's substitute. We have 2x all squared is 4x squared. 2 times 2 times 2 is minus 8x, then plus 4. This is 9x. So like terms together, we have 4x squared minus 8x minus 9x, it's minus 17x, plus 4 equals to 0. We can factorize this. So we will have 4x minus 1, and we will have x minus 4, so which is 0. So in other words, x is 1 over 4, or x is 4. So getting the values of y, we know that y, we said it's 2x minus 2, so y is We substitute. If we put a 4, we will get 2 times 4 is 8 minus 2 is 6. If we put a 1 over 4 minus 2, so this will be 2 times 1 over 4 minus 2, it will give us negative 3 over 2. So we will have our 2 sequences. So it means the first one will be 2 if x is 4, y is 6, and then we have a 9. Or the other one will be 2 if x is 1 over 4, y is negative 3 over 2, and then we have a 9. So we can be able to calculate the 2 values of x and y, the values of x and y, if this we have both the arithmetic and a geometric sequence combined. Thank you very much for listening to this lesson. Please don't forget to like and subscribe. Thank you. We will meet into the next lesson where we are looking at the summing the geometric sequence. Thank you very much.